Okay, hey everybody, welcome to the show. This is the Amazon DocumentDB Insider Hour, June 17th. I'm joined by my co-host Karthik Vijay Raghavan. Say hi to your fans, Karthik. He's on mute.
Hey guys, nice to
Yeah,
meet you all again. Looking forward to this session today.
yeah, Karthik is riding out the heat bubble in Dallas, fast on the heels of a blizzard. Like, what was that, like 2 weeks ago, that took down the electric grid in Texas? Feels like it was just like very recently. Now we're breaking heat records. It's crazy. And we're also joined by special guest Meet Bogdev. He's the senior product manager for DocumentDB. Meet, welcome to the show.
Hey everyone, thank you, Chad.
All right, well, we're just going to dive right into it. Meet's here to talk to us about a very special new feature called Global Clusters, which we've been eagerly awaiting. Many customers have been eagerly awaiting the ability to replicate data across multiple AWS regions. So we're going to just have Meet jump right in, and he's going to tell us all about it, give some demos, and answer any questions anybody might have. So Meet, take it away.
All right. So hey everyone, like Chad said, I'm a product manager on the DocumentDB team. Today I'm going to talk to you guys about Global Clusters. Global Clusters is a new feature that we announced recently that aims at providing disaster recovery to our customers from the region-wide outages and enables global reads for your applications. Fun fact, this was actually one of our top feature requests. So pretty much, think about all our big customers. This was one of those features that was very near and dear to a lot of them. So we're just really excited to finally have it released. The kind of workloads that this is ideal for are ones that have a global footprint and strict availability requirements. So the way to think about it is, prior to global clusters, you could only deploy your DocumentDB databases in one region. If that region were to go down, which doesn't happen much, I think it's happened once in the last, X years, in that event, you would have unavailability for your application. Now, if you think about some of the biggest apps today, think about the e-commerce giants of the world, they cannot tolerate that kind of unavailability. So these customers have really strict availability requirements, and they need to be able to tolerate a complete region outage within a minute and recover from a complete regional outage within a few minutes or even seconds in some case. So for these customers, Global Clusters is a very key feature. It launched on 2nd June, so just a couple weeks ago, and it's available on all DocumentDB clusters running version 4.0 and above. So it's not one of those things that you need to opt into or somehow add it to your cluster. It just automatically becomes available in your patching window, which should have already passed, provided you're running version 4.0, and in the future, the next versions that will release. Two use cases, like I alluded previously. The first one is disaster recovery. So with global clusters, we'll give you the ability to promote secondary clusters in any of your secondary regions to become the new primary cluster within a few minutes. This is, again, ideal if you are looking to go for a faster recovery process from a regional outage. Prior to this, we did have another feature that several of our customers used called cross-region snapshot copy. That would have allowed you to copy snapshots of your cluster across regions and then save it in a new region for X number of days. So should a disaster were to happen, you could just go create a new cluster in a secondary region from the snapshot. That worked for most of our customers who didn't have strict availability RPO requirements, which stands for Recovery Point Objective. So if you as a customer can tolerate multiple minutes of downtime, that's good. It works for you. But for customers who cannot, that was kind of a wrench. So Global Clusters helps solve that one use case of fast disaster recovery.
All right, so just to be clear, this is an architecture where one region can accept writes, that's the primary, and the other regions are read-only, correct?
That is correct. So it's an active-passive architecture, which means you can have one primary region and up to 5 secondary regions. And I'll get to that in just a bit. But yes, all the writes are going to your primary regions. In the screen, if you see, you have the P. That's the region that's accepting all the writes. And then it's replicating these writes over to various secondary regions in America and across the globe. The second use case is global reads. So with global clusters, you can essentially serve reads for applications in regions outside the one your primary cluster is in. So it's ideal if you have users in different regions and you're looking to bring data to them faster. You're able to do that with global clusters because all your secondary clusters, not only do they provide a good disaster recovery option for you, they also provide a fully functional database that you can target and run queries against. The caveat, like Chad mentioned, it's only reads. We do not support global writes at the current moment. So for disaster recovery, just some stats. A lot of customers are often curious as to, okay, well, what kind of replication lag are we talking about? How fast could I really fail over if an outage were to occur? So to answer to those questions is you'll have lag across regions typically be milliseconds and typically less than a second. This is obviously not a guarantee. If you're going from, let's say, America to Australia or some regions that are really far and you're running some sort of an ETL job, it could be a little bit more than a second, but typically what we've seen in all our testing and what our customers are telling us based on the recent feedback is typically milliseconds. The way to look at it is it'll be less than a second. So that's the replication lag. Customers are also curious about the recovery time objective. This tends to be very important if you're looking to recover from a regional outage. So with global clusters, you can promote one of your secondary clusters to become the primary cluster in less than a minute. The whole promotion process, once you go to the console and click promote, which I'll show you a demo of very soon, is very fast, and we've seen it be basically in the less than a minute kind of range. And last, I think this one's not very common, but with global clusters, you can also have fast cross-region migrations. So let's say you're looking to migrate from region A to region B. You can just add a region to one of your existing clusters. We'll replicate all the data over for you. And now you have a copy of your data in the second region, which you can then use for whatever purpose you'd like.
Is there just on the first bullet point, is there a sort of CloudWatch metric that people can look at to see what the replication lag is, something they can monitor?
Yep, there is. So we have a CloudWatch metric on replication lag, which you can monitor for each of your secondary clusters. So let's say you have one primary cluster and 3 secondary clusters. On each of your secondary clusters, and I'll show in the demo, on each of your secondary clusters, you can actually monitor how much lag are we talking about across regions. Okay, so just to walk through an example here. So in this diagram, as you see, we have a primary region in US East. Prior to global clusters, this is all you could do. You could have one primary region, which could have one write instance, one read instance, could have actually up to 15 read instances. In this case, we have one write instance and one read instance, which is sending data to your primary region and you're reading from your primary region. Now with global clusters, you can very easily add a new region in Europe. So what I've done here is I've just extended my global cluster such that I have a primary region in US East and a secondary region in EU West. I can actually go even further and extend and by add 2 more regions. So I added a region in US West and another one in AP Southeast. The one thing to kind of keep in mind here is all the secondary clusters will only be able to serve reads. So the R here stands for a read replica instance, which means your secondary clusters will only have read replica instances, which will help you serve reads. And in this case, once you've set this kind of topology up, the replication is fully managed for you. It's automatic. So as you push more writes to your primary region in US East, DocumentDB will automatically replicate this data across these various regions for you.
Well, from a programmer's point of view, the app instances, let's say, that are running in EU West using the MongoDB APIs, do you need to create 2 instances of those MongoDB connections, one for the reader side talking to EU West and one for the writer side talking to US East? Or does it automatically sort out all the writes automatically go to US East? Does the driver
So,
sort that out?
so each cluster, each region has its own endpoint. So in this case, we're looking at 4 endpoints, one for US East, one for US West, one for EU West, and one for AP Southeast. So let's say you have an application in Europe that is serving reads. You're connected to the EU West endpoint, and you're processing reads for your application. Now, if that application were to want to write something to the database, that won't work because the endpoint the application is talking to is a read endpoint. So then you'd have to set up a new connection that would help you write that data to US East, which would have to be a different endpoint. At the current moment, we do not support a global endpoint. That is something that we are looking into in the future, but that's not something you're able to do today. So specifically for kind of the global application scenario, it will require a little bit of custom setup in your applications. However, for disaster recovery, the failover process is quite simplified, which I'll walk through later.
So you would need to have some sort of configuration map somewhere saying which region was currently the primary region, right?
That's
so
correct.
That when you start up, you kind of go read that and go, oh, okay, well, it's not US East anymore, it's AP Southeast or whatever.
That's correct. That is correct. And again, to call out, regional outages are very rare. So, 99.999% of the times, you're not going to have to deal with a regional outage. So this only becomes important if you do. Like your primary is not typically going to change. So the event where the configuration map does come in handy is valid, but I do want to call out that it's still a rare event.
Yeah, it would be rare.
Right.
I'm just always thinking of customers like Netflix or whoever that are using, the chaos monkeys to take down whole regions and such.
Mm-hmm.
Just to make sure their code can deal with it. So that's kind of how they'd have to deal with it, right?
Yep, that is correct. Cool. And then the second scenario, like Chad was talking about, I think global reads for global applications. We see this more and more nowadays as customers no longer have users just in a given region or a given country. A lot of our customers tend to be global customers. Think about the Netflixes of the world, the Ubers of the world. So these customers are very interested in serving global reads from regions it's from multiple regions, not just one region. So with global clusters, you're able to do that. The replication itself doesn't have any performance impact to your clusters. So when we are replicating insert, update, delete events from your primary to your secondary regions, we offload the entire replication process to our storage layer. So your application doesn't feel any sort of burden when you add regions. If you go from 1 region to 2 regions to 3 to 4 to 5 to 6, all of this replication is offloaded to our storage layer, which makes it really easy for global applications because you don't want to make a trade-off between going global and throttling latency. So with global clusters, you're able to do that. Replication across regions is virtually no performance impact to your primary region, given we offload that to our storage layer. So to kind of round this up, a typical deployment of a global cluster would look similar to the one I'm showing on the screen here. So in this case, I have, let's say, a primary region in Ohio. On my primary cluster, I have 1 write instance and 2 read instances. Now, I want to add a couple of more regions for disaster recovery and also for global reads. So in this case, I've added 2 regions, one in Oregon. So that's one of my secondary regions. And I've spun up 2 replica instances on my secondary region. And I've added another secondary region in Tokyo. And I've spun up 2 more replica instances in that region. So now if I were to insert from my app 1, which is in Ohio, let's say I'm inserting a document X1, that document's going to get inserted. Once it reaches your storage layer, the replication service is going to replicate that data across both your secondary regions in less than a second. Again, not a guarantee, but something we see typically. Once this data lands in one of your secondary regions, you're able to read. So for instance, app 2 over here is able to go and run a command, which is db.foo.find, and then it's going to get x1 as the returned result. The one thing to kind of keep in mind here is replication for global clusters is async. So because it's async, that is why you see a bit of a lag. We don't take a lock on your events being replicated across regions, and that is how we guarantee that there's no performance impact on your primary cluster. So there is let's say if there's a regional outage, the chance of data loss is very minimal, but in the worst case, you could see, let's say, up to a second of data lost. And at that point, you kind of need to make a trade-off between, okay, it's a disaster recovery use case. Am I able to tolerate that up to 1 second of data loss, which could happen with the way global clusters works in DocumentDB? That said, it's pretty fast for most use cases. That kind of lag is acceptable, and given it's a disaster recovery kind of scenario here, most of our customers are typically okay with that kind of lag.
Has a similar lag to what we see on DynamoDB global replication, for example.
It's very similar. Exactly. It's very similar to Dynamo. It's very similar to also Aurora's global databases, both for MySQL and Postgres. So if you're looking for something to kind of grok and compare against, it's a good call, Chad. Very similar to other database services.
Are there any ordering guarantees that are made during this replication process, or how does that work?
Yep, there absolutely is. So let's say you're running a transaction, which is typically the all or nothing behavior. So I'm inserting 100 documents on my primary region inside of a transaction, which means either all 100 are going to get committed or none of them are going to get committed. So in that event, Global Clusters is going to wait for your transaction to complete. Once the transaction is committed, which means all 100 documents were successfully inserted, it will replicate all 100 of those onto your secondary clusters. On your secondary clusters, you'll get the same ordering and transactional guarantees. So you'll either see 0 of those documents, or you will see 100 of those documents. The same sort of ordering that your primary cluster gets, you'll see that on the secondary cluster. And the same sort of transactions that you see or read from a primary cluster, you'll be able to do the same on your secondary clusters.
Wow, that is outstanding that the replication service is transaction aware. That's awesome.
Absolutely. Yep.
What about discrete write? Let's say I insert document A and then I insert document B. Will the replication service replicate it in that order guaranteed, or how does that work? Not under a transaction.
Yes, it will. I don't I'm pretty sure it will. Like, I'm happy to follow up with folks on my team to confirm that. But from what I'm aware and what I've seen from the various workloads that are running on global clusters, that is something that we do offer. I'm not 100% sure whether it's a guarantee. I know for transactions it's a guarantee. I'm not 100% sure whether it's a guarantee for non-transactional rights, but if I were to put my money on it, I'd say yes. But it is something that I'm happy to follow up on if any of the folks in the audience have questions on.
Cool.
One more thing on that, right? So when you're writing data, is there a way to force to get a response only after the data is replicated to at least 1 or 2 secondary regions?
Not in a managed way at the current moment. So short answer is no, unless Karthik, you think otherwise. But yeah, as far as I know, that's not something it's async. So there's no way for you to force a sync across regions. That's something that we're happy to work with customers if that's something they're interested in.
Understood. Okay.
It's just some metrics. I'll just kind of quickly go through them. I think I mentioned them before. You can have up to 5 secondary regions. That means total of 6 regions, 1 primary and 5 secondary. Lag times of less than a second, recovery time in the event of a regional outage of less than a minute, and high throughput. So this is important because our replication is offloaded to the replication service. You continue to get the high throughput that you get from a single region setup. So because of 2 secondary regions, we're not going to slow down your writes. Your writes are going to be as fast as they previously were, because all the work is being done by the replication service. Your compute instances are still running at the same capacity they were before. And this actually is a key differentiator versus some of the other solutions that you see out there in the industry. So you can get up to a million or 2 writes per minute with this kind of deployment. It's available on version 4.0 and above. So what about read replicas? How many of them can I have? So with global clusters, you can have up to 90 read replica instances spread across 6 regions. Again, this is all without impacting your database's writer performance in the primary region. So let's say you go from 1 primary and 3 read replicas to now 1 primary and 30 read replicas. It will not impact your workload. And as you add these replicas, there is 0 downtime to your application as well. So all of this is fully transparent, and you can go all the way up to 90 replica instances across your 6 regions. You can also obviously delete, add, any sort of create, update, delete, add operation. Will be no downtime for these read replicas and will not impact your application's performance. So if you have an application that requires billions, millions, and billions of reads per minute, and you want to span those out across regions, you can very easily do that with global clusters, albeit not the primary use case. It is something that's an added benefit that you get as a result of how we've architected it. Okay, so how does this really work? A lot of our customers ask us this question is, okay, well, this is all great, but can you kind of peel the onion a little bit? So in this case, I'm going to just walk you guys through exactly how the replication process works. So in this case, I have 1 primary region and 1 secondary region. And over here, you have a replication server, which is going to receive any write events on your primary region. And you have a replication agent, which is going to listen on the replication server and take any sort of write events and apply them on your secondary cluster. So first step, you have a primary instance, and you have an application that inserts a bunch of documents. So as these documents come in, they're synced across your storage volume. Once they make it to your storage volume, they are also sent over to the replication server, which is running if you have a global cluster deployed. So the replication server at this point is receiving any sort of, let's say, an insert, update, or delete event in async mode on your cluster. Once, let's say, the record is committed, persisted, etc., the replication server will then stream these records very fast to the replication agent in the secondary region. So over here, step 2, as you can see, all of these insert, update, delete events that we inserted, they're streamed over to the replication agent on the secondary region. One thing I want to call out is replication for global clusters is not logical replication, but instead physical replication. So we don't use necessarily a log-based replication model. We actually literally physically replicate those documents over to a secondary region, which has several benefits. The primary one being it actually does not impact any of the performance of your application. So everything's offloaded, and it's a physical replication from our storage volume through the replication server. So then the replication agent receives these events and then streams them to the storage node through the instances. At this point, any sort of inserts, update, deletes that you performed on your primary are persisted on your secondary. And once they're persisted, at this point, you have a fully functional secondary cluster, which will have backups to S3, which will have an endpoint that you can target and read from, set up auditing, set up the profiler, etc. And the final step, the replication server pulls from storage nodes to catch up. Let's say if there's an outage, in that event, pull any log records that need to catch up after the event of an outage. So to kind of summarize, the key point to kind of grok from this slide here is all the replication for global clusters is offloaded to a specific server and agent, which constantly listen on any sort of change events, replicate them over across regions without any sort of impact to your application's performance.
Hey, Meet. So on the secondary region and step 3, the replica instances will be updated only if I'm performing a read operation on that region, right? So that it keeps those records in the replica instance fresh. It's not just going to be updating all the replica instances with any data that's being replicated to the secondary region. Is that right?
That is correct. We do update the metadata on the replica instances. So let's say you have an index, right? Let's say you have an index that is stored in memory. And let's say you now wrote a bunch of documents which require an update to that index entry. They will push those kind of statistics to the replica instances such that the cache remains fresh. But other than that, you're right. We don't touch the replica instances unless there is something that actually needs to be updated on those instances, which typically happens when there's a read.
Got it. Yeah. So as long as it is a pure disaster recovery scenario where I'm not doing any reads on those instances, there should be almost 0 to no updates or pretty minimal updates to the replica instance, if at all, for any metadata.
That's correct. I was actually going to get to something along those lines. Let's say you don't have a use case where you need to do global reads, and your use case is primarily disaster recovery. In that case, you could actually run your secondary cluster in a headless mode. And what headless means is you don't need to have any of these instances. All you need is the storage volume. And global clusters lets you do that. So with that, all your change events keep getting replicated to your secondary cluster storage volume. And if a disaster were to happen, you could at that point add an instance to your cluster. Why would you like to do that? Well, it's really cheap to do this. Instances cost money. Storage is very cheap. So let's say you're just looking for disaster recovery and you're able to tolerate, let's say, multiple minutes of downtime in the event of a regional failure. In that case, you could just run your secondary regions fully headless, which again is a key differentiator for us. And by running this in a fully headless form, you get to save a lot of money, which obviously is beneficial for several of our customers.
That's awesome. Yeah, I have not seen any other product out in the market doing that. So I think that will be a significant cost savings for pure disaster recovery solutions.
Indeed.
That's interesting.
Do you think at the beginning most of the users of this will be DR users?
So that's when we've talked to like hundreds of customers that have been waiting to use this feature. More than 90% of them are looking to use this feature for disaster recovery. That's kind of the primary use case. There are obviously a certain small set of customers that are looking to deploy this through a global lens, which is where the global reads come in more handy. But the primary use case that we're looking to solve with global clusters and what we've heard from our customers is disaster recovery. So it's more of a peace of mind kind of functionality where if a regional outage were to happen, you don't want to kind of get stuck trying to recover from it. You just want to have a nice push button experience. And that's what this feature provides.
What, from an economic point of view, since we're talking about saving money by running headless, how does the pricing work for this replication? Is it like DynamoDB where there's different price for replicated writes, or how does that all work?
Nope. Here? So any sort of IOs that get replicated over the wire are billed the same way regular IOs are. You do pay. Let me take a step back. You do pay for any IOs that are replicated across regions. You also pay for data transfer per gigabyte for data that's replicated across regions. Other than that, the pricing for global clusters is the same as DocumentDB. So you'll pay for storage, you'll pay for instances, and you'll pay for any sort of read IOs on your secondary region. The only additional cost you'll pay for any of those writes that got replicated over the wire, and that is billed at the standard rate as the typical write IOs on DocumentDB. So it's not extra; it's the same price.
Oh, that's awesome. And so really, the only thing you're paying for is the data transfer across the wire.
Correct. the data transfer and the replicated write IOs, which you won't have to pay for if you had only one region.
Right. No, that makes sense. Cool.
Mhm.
Wow.
Hey, Neil,
Yes.
sorry, just one more question. So is it possible to filter, or will it be possible down the line maybe to filter on what I want to replicate? Let's say I have like 5 databases, each with 4 collections. What if I want to replicate just a couple collections per database? Is that possible?
It's a good question. It's not something we offer today. It's essentially a fully managed replication experience today. So any event, anything, insert, update, delete, create, like any of these events that tend to be DDL DML style will get replicated across regions. We don't let you filter today. It is something that we've heard from a couple of customers. Unfortunately, I don't have a firm commitment or any sort of roadmap that I can share, but short answer to your question is not something we offer today.
Okay, thank you.
So yeah, they can always just make another cluster and have the stuff they want to replicate in a separate cluster, though. I mean, I guess that would be
yes, they can do that.
Yeah.
Yep. It's not a very ideal one, but yes, you could always have different clusters. One where you have a collection that needs to have kind of cross-region availability, and a few other collections that are maybe dev test or not that important, or reference collections which could just live in another cluster. Totally a fair solution. Yep, that would work.
That would probably be through a dump and restore from or maybe a dump and restore from that collection, right? Because with restore, I can say, hey, move this collection and move this database.
Mm-hmm. Correct.
Got it.
Cool. So key differentiators, just to kind of round these up, I think I'd mentioned them sparingly throughout the presentation. The first one is, because we offload the replication to the storage volume, there's no impact to your workload's compute instances, and thus no impact to your application's performance. This is very, very key when customers are looking to evaluate solutions. Oftentimes, cross-region solutions end up impacting application performance. For DocumentDB and global clusters, that's not the case. Secondary clusters also give customers the flexibility to control the number of instances you want to have on the secondary region. For instance, your primary region could have 10 instances, 1 write instance and 9 read instances, and your secondary region could have only 1 read instance, and that's perfectly fine. So you get to control exactly how many instances you want on your secondary regions. You do not need to match the number of instances on your primary cluster. This is very useful because it helps you save cost, especially if you have a large workload with a lot of instances on your primary region and your primary use case is just DR. You can have a very skinny secondary cluster with just one instance, which we recommend you at least size it to match the primary, but you don't need to have the same number of instances. So that's a key differentiator. And to kind of take that step further, secondary clusters can operate in headless mode. So not only do you get to control the number of instances, you could literally have 0 instances, which, like I mentioned earlier, is very useful if you're looking to save cost. The caveat here, though, is we recommend that you only do this if you are able to handle up to 30 minutes of downtime, because let's say a regional failover were to happen and you need to spin up a new instance, it could take a few minutes, which we want to be mindful of. So if you have a workload that can tolerate that kind of downtime, you can operate in headless mode. You'll save thousands and millions of dollars depending on how big your cluster is.
We do have a question. We do have a question
Yes.
in the chat. Let me throw it up on the screen. For a data analysis application, would you deploy instances of the application next to each replica, or one application which knows about the single logical connection string endpoint in front of the AWS data instances? I think the answer is you could do it either way, and it depends on really what your needs are, right?
That's correct. So data analysis application, I'm assuming this is some sort of a reporting use case where you have applications in each region, if I'm getting that right. So I think if that's the case, I think the short answer to that question is whatever works best for you. You have the option to do either. And I think it depends on your goals and use cases. The single logical connection string, though, I think I want to just poke on that a little bit. If you don't have a global endpoint, I think I called that out earlier, there's no way to just connect to the global cluster with one endpoint. Each region has its own endpoint. So you can obviously connect through the regional endpoint. You don't have to connect to the specific instances, but you do have that caveat that there's no global endpoint that lets you just connect to all your replicas across regions. That's not something we offer today.
Yeah, I would say most of these reporting applications don't run in a multi-region fashion, right? They just tend to run in one place, and they probably just want to talk to a local copy of the data. So usually when we see people do this, they pick a region for it to run in, probably the primary region where all the writes are happening, and then they can have their own separate read replica, right? That only they use, right? And they can use that read replica's endpoint or that instance's endpoint directly.
Correct.
Yeah.
Yeah, I was going to say that, Chad. So if it is just an analytics application, and all that you care about is a dedicated instance to perform some complex queries, I mean, you don't have to use global cluster to create another cluster. You can just use that instance endpoint. That will be more economical. But if you are planning to replicate data, like Meet was showing in this key differentiator slide, right? So you can on the destination cluster have not only smaller instances but also larger instances, and use that as your analytics cluster in the scenario, right? So it's up to the the workload and the needs. You can solve this within a single regional cluster, or use one of the secondary region in the global cluster to perform those data analytics.
Correct. Cool, good question. Feel free to send questions, by the way. I think we're almost done with the content. I think what I have next is I have 3 demos that I'm going to show you guys. The first one is how to add a region to an existing cluster. So going from one region cluster to multi-region cluster. Next, I'm going to show you how to perform global reads. Basically walk through how to connect to some of these secondary clusters. And third, which is the fun one, is how to promote a secondary region in the event of a failover. So these are the 3 demos, and I will actually get right into it. Can you guys see my screen?
Yes, we see the console.
All right, cool. So here I am in my DocumentDB console. If you are familiar, sorry, I'm just going to refresh my credentials. If you guys are familiar with DocumentDB, this console should look very, very familiar to you. I'm going to switch over to Ohio, which is going to be my primary region for the purposes of this demo. So in Ohio, I have this one cluster. It's called DocDB demo-twitch-1. So this is my regional cluster. If you see the role column, it will tell you whether it's a global cluster or a regional cluster. And this cluster has 1 primary instance and 2 replica instances. Now, I want to make this a global cluster. What do? Well, you click on the cluster. And once you click on the cluster, you see this Actions tab here. Once you go there, you'll see a new option now after 6.2, which is called Add Region. So at this point, I'll click on Add Region, which will take me to the screen where I get to pick what region do I want to make my secondary. So you get to see all of them. I'm just going to say I want my secondary region to be in Oregon. Here you need to give a global cluster identifier. So this is just a 1-step process because you're going from a regional cluster to a global cluster. You need to give your global cluster a name. So I'm just going to say docdb twitch demo-global. Then you have a cluster identifier, which I'm just going to say demo2. You get to pick your instance class. I just want to match what I have on my primary. And I don't need 3 instances. Like I mentioned, if it's a disaster recovery, you just need 1. As you can see, it helps you reduce your cost. You can tweak your advanced settings. Don't need to do much of that here. And then you go ahead and create.
Oh, okay. So you do need a minimum of 1 instance. It's not 0 instances.
No, you could do 0. I'll show you that later. It's just during the provisioning flow, you can't by default provision headless,
Oh,
but you can
okay.
definitely achieve headless state once you've gotten that one instance. It's one of those things that we're looking to improve through our UX.
Got it. Okay. You
but
could
it's not
remove that instance later, basically.
correct.
Got it. Okay.
Okay, cool. So at this point, as you guys see, my secondary region is coming up in the US West. So now my cluster, which was a regional cluster, just got promoted to a global cluster. And inside of my global cluster, I have two child clusters, if you must. You have a primary cluster, which was our original one, and then I have a secondary cluster, which I just created. I can just go and add more. So even while another cluster is coming up, you can just go have fun and add another cluster.
Is the time to provision dependent on how much data is already in the cluster?
It is not. So like I said, all of the replicas. So the time to provision is basically how long it takes for your instance to come up. And once your instance is up, you can start running queries against it. So short answer is like you could have a gig of data, a terabyte of data. The provisioning times will be very similar. They don't scale linearly. They might have a couple of more seconds here and there if the cache needs to catch up, but generally speaking, they're very close.
That's great.
So as you can see, now I have two regions. This is the primary and then two more secondaries. Cool, and that's basically it. So while this is creating, it'll take a few minutes. And in the interest of time, what I've done is I've actually spun up another cluster already. So I already have another demo cluster called DocDB Global Demo, which has 3 regions, DocDB Region 1, DocDB Region 2, and DocDB Region 3. So what I'm going to do now is I'm going to show you guys how to connect to these and perform global reads. So let me switch over. One second. Let me know if you guys see my screen.
Yep, we can see your terminals.
Okay, cool. So here I'm showing 3 terminals, and I know it's just like a bunch of black text or black background right now, but it'll get a little more interesting very soon. So on the left here, I have my primary cluster. So I'm just going to connect to that. And then it will show you that it's RS0 primary. So that's our primary cluster in our global region. And here I'm connecting to my secondary. So as you can see, this is my secondary cluster's endpoint. So let's go ahead and connect to that. And that's RS0 secondary. And then I have one more secondary. So I'm going to go ahead and connect to that. Cool. So I'm connected to all my clusters. Now on my primary cluster, I'm just going to run show DBs. And as you guys can see, I don't have any DBs. There's no databases. Similarly here, no databases. No databases. So what I'm going to do now is I'm going to insert some data. So just some sample documents. And I'm just going to say use demo, which is going to just create a demo database. And I'm going to insert some documents inside that database. So I'm inserting just 3 employees, Chad, Karthik, and myself, into this collection. And at this point, it says successfully inserted 3 documents. And now if I do db.empdetails.find.
We all have 900 phone numbers, I guess.
Exactly. So I just did a find. And as you can see, there are 3. I'll actually clear my screen so it's easier. There's 3 documents that I just inserted. So previously, there were no databases on my secondary. Now if I do show DBs, the demo one shows up. I'm going to use the demo. And I'm going to do db.empdetails.find. And the same 3 documents now showed up. I'm going to do the same thing here. If I run show DBs again, the demo one shows up. Replication's fast. I'm going to use the demo. I'm going to run empdetails.find.
You have a typo, that T.
Keep adding that damn T. All right, cool. So now all of my secondary regions have these 3 documents. Just to make it a little more fun and show you guys how quick the replication is, I'm going to insert 2 more documents. So I'm inserting 2 of my additional coworkers to the employee details collection. And I insert. Now if I do a count, I should see 5 documents. There you go. And I'll do the same here. There's five documents on both my secondary regions. So this just shows you that you can keep inserting documents on your primary. Once you connect to your secondary clusters, everything just gets replicated. It's automatic. You don't need to set anything up. As soon as your secondary cluster comes up, all of this just is taken care of for you right out of the box. Any questions on this?
Like magic.
Indeed. Cool. And then the last demo. So I'll go back to my console. Sorry for jumping around. All right. So now I'm back into my console. And what I need to do is the third demo I wanted to show you is how the hell do I promote one of these secondary clusters to become the primary? This is useful. Let's say there's a regional outage, and the first region is just gone. So your primary region, which was previously docdb-region-1, is just straight up not working. So in that case, what you would do is you would connect, you would select one of your secondary regions, you would go to Actions, and then you would say Remove from Global. So when you do that, what you're doing is you're basically promoting docdb-region-2. And what it's going to do is it's going to stop replicating from the primary region, which makes sense because the primary region's dead right now. And it's going to promote it to a standalone cluster that can serve both read and write traffic. So all I need to do is click this command, promote. And now if I refresh this a bunch, it'll take a minute or so, but basically that cluster which I just promoted will then become, you'll see the status will turn from available to promoting, and around a minute's time, it will basically show up as its own cluster. In the meanwhile, if you go back to our previous clusters that we just created, as you can see, the primary was up and the secondary primary was already up, and the secondary ones are created. They're almost done creating. It takes a few minutes, but in just about 10-ish minutes time, you'll see those live as well.
Hey, Meet, quick question on the first cluster, right? So the global cluster, DocDB global demo, you are promoting region 2 to a standalone cluster.
Correct.
So, again, this is under the assumption that region 1 is down. In that scenario, what happens to region 3? Is it still going to be available?
Great question. So it will still be available, but it's not doing anything at that point, right? Because your primary is down at that point, so it's not getting any sort of replica instances. So at this point, that region will just be an orphan. So it's just available, but it's not able to process any reads because it's not getting any sort of events. You can still connect to it. The data will just be stale. You won't have any fresh data. So while that region will be there, it doesn't serve much of a purpose in the event of a disaster. So what you'll have to do is you'll kind of have to recreate this topology such that you have this region 1, region 2, region 3 once the regional outage is, let's say, over.
Got it. Okay.
We did have a question. Throw it up here. Your console shows US East 2, etc. in the URL. What happens when US East 2 is offline? I think if you switch to another region, you'll see that the URL changes. Each region has its own separate URL for that console.
Okay, think I follow, but I'm not fully.
So someone's just asking what happens to the URL if the region is offline, and the answer is that each region has its own different URL for accessing the console.
That's correct. So I just
also global cluster, right? So you should be if it is about, like, I think the question relates to if this is offline, how do I go even and promote, right? So since the cluster is global, you should be able to access this in any region, right?
Yep. Exactly. So for instance, let's say Ohio was down. and I'm just trying to access the damn console so I can promote one of my regions. Like I can actually go to like Ireland, for instance, and I'll see my cluster. Like I'll see my global demo, even though US East is down. So the global clusters are available across all regions because they're global. And you can go to EU West 1, for instance, if you want to promote this region. You can go to EU West 1's console, which I think I am in. I can go here. I can go to Actions. I can just say promote this one. So now it will promote yet another region. So good question. Like if the region's down, the console is probably also down, and that is true. But if that were to happen, we'll do it in such a way that you are able to still promote regions from the other region's console.
I think I missed something. Why is it that you're removing it?
So at the current moment, the promotion process requires you to remove the cluster from the global cluster and promote it to a standalone cluster.
Oh, okay. And then when the other region comes back on, can you rejoin?
You basically recreate your topology, yes. So in a way, it's you kind of instead of rejoining, you have to recreate your topology.
Okay.
So the previous one that we just promoted, which is DocDB region 2, is now available. It can now serve reads and writes. So for instance, if I were to go here and I were to copy this connection string, go back to my terminal, for which I'll have to change my screen again. So we're in the middle window right now. And if I connect to it, and now it's a primary. So previously it used to be a secondary, it just got promoted, and now it's a primary. And now I can insert documents. The previous database should still be there. We didn't process any writes in the last few seconds, so it should still have the 5 documents. Still has the 5, and now I can actually go and insert 2 more if I want. That's me, that is. It's inserted 2 more, and now I have 7. So what I showed you is how, in the event of a disaster, like let's say a full regional outage, which again are very rare, I literally took one of my secondary regions, promoted it to a regional region, a cluster that could serve both reads and writes, and now instead of it being a secondary that could only do reads, I can now go and insert, update, delete documents from this from the secondary that I promoted. One of the key features a lot of our customers are already asking us for is a managed failover. A managed failover is one where you don't have to go and kind of restitch your cluster. When the outage is over, you get the ability to kind of just automatically rejoin, or it just automatically goes back to the original form with a push of a button. That isn't a feature that we support right now. It is, however, one that we are looking to add in the future.
Okay, so for right now, the failover process would be, let's say I have 5 regions, and region number 1 is the primary. The other 4 are read-only. So if region 1 goes down completely, I want to fail over to region 2. So I remove it, I fail over, and then I have a regional cluster, which I then go create 3 more regions and convert that to a global cluster and add 3 more regions to it. And now I'm back to my 4 region cluster.
That is correct. There's a document that outlines all the steps. Obviously, you can script and automate them, but the flow that you described, Chad, is exactly it.
See if we can find that document and post it in the chat. I don't know if you have it.
I have it. I think I'm just going to post it here.
But while we're doing that, somebody asked, is there any provision to get previous episodes? Yes, there is. If you go to the DocumentDB resources page, which I'll post a link to, right here. So if you go to
Yep.
the DocumentDB resources page and scroll down to Amazon DocumentDB Insider Hour, all of the past episodes are up.
Yep. Cool. So I think that's all I had for my demos. I shared the link to the doc, I think, on chat if you're able to pass it on to the audience, if you're able to do that. But I'll just share my screen as well. So if you go to our docs, we have a dedicated page on disaster recovery for DocumentDB global clusters. And it basically walks through what do you need to do specifically to promote, let's say, a secondary cluster. So it walks through all the steps. Like I mentioned, it is one of those things that we're constantly looking to improve. So we do have like a feature called managed failover that we're looking at in the future that hopefully addresses some of the pain points that we just referred to. Cool. Anything else? I think we've got, what, a couple of minutes?
Yeah, we're basically at time here. Oh, Karthik posted a link here. If you want to follow this page for past and future episodes, you can do that. The link is in the chat. All right, Meet. Thanks very much for joining us today. This was a great informational session and demo. I imagine this will be our most replayed episode probably from this point forward for a long time. Because it's
I hope
such
so.
a great feature. Yeah.
And if folks have questions later on, feel free to send us an email or find me on Twitter. There's, I think, only one person with my first name, last name, but happy to put my handle. Happy to answer any questions or work through any use cases, or if something doesn't work for you. Also happy to schedule a call with you and understand what exactly doesn't work for you, so we can help improve it as we continue to invest in this feature. It's going to be one of those features that we're going to constantly invest in the next 2 years. So very eager to hear your feedback and hoping you guys get to use it.
Absolutely. All right, Meet. Thanks for the info, Karthik. Thanks for joining.
All right. Thanks, everyone.
We'll see you all in
Bye-bye.
a month. We'll be back here 1 month from today. Bye.
Take care, guys. Stay safe.